All right, we're throwing stuff off buildings now. How rude. Okay, so we launch from here with our initial velocity of 15 meters per second, but that's at a weird angle, and that helps nobody. So we're going to split this into its x component and y components. That's a dotted line. This is a right angle, that's our theta. So this is 15, it's opposite the angle, so we're going to go sine theta, and this one's adjacent to the angle. So that's 15 cosine theta. All right, so that's 15 times the sine of 53.1. Be sure you're in degrees, not radians. So that's basically, that rounds to 12 meters per second. That's our initial velocity in the y direction. And then the cosine is 9 meters per second. Ish. We're rounding. We'll live. Okay, so let's make a list of all the things we know. In the x direction, our initial velocity is 9. Our final velocity is also going to be 9 because our acceleration in the x direction is 0. Even the fastest baseball pitcher in the world, he doesn't have acceleration in the x direction because he can't keep pushing the ball once he lets go. Once let go of the rock, there's no acceleration. How far did it get in the x direction? We don't know. How long did it take? We don't know. We don't know anything. This is not the way. Let's try y. Our initial velocity. Oh, so I'm going to, we are here, and then we have this journey down here. I'm going to start here. Okay, at this moment in time. So our initial velocity there will be the same as our velocity coming out. So the initial velocity is 12. Our final velocity down here, that's what we're looking for. We don't know, and that's okay. The acceleration is 9.8 because it's gravity. How far did we get? 20. How long did it take? We don't know. We don't care. So let's find a kinematics equation that doesn't have time in it. That'd be the squared-y one. So final velocity squared equals initial velocity squared plus 2ax. So final velocity squared is 12 squared plus 2 times 9.8 times 20. So if you do that algebra, 2 times 9.8 times 20 plus 144. Don't forget your square root. You get 23.15. And I messed up. And I was like, 23.15 isn't an answer. The answer key is wrong. No. So that's the final velocity in the x direction. Or sorry, the y direction. That's 23.15. Our x direction, we never slow down. So that is still 9. So we need to figure out, that's a right angle. We need to figure out what's our final velocity here. So I'm told y'all have a pinky up fancy formula. I told my kids to just Pythagorate. A squared plus b squared equals c squared, so 9 squared plus 23.15 squared equals c squared. Square them, add them, take a square root. You get 24.8. That's A. If instead of kinematics you wanted to do energy, that is also totally valid. So, whoa. Okay, so let's talk. I'm going to change colors because this is an alternate way to do it, but it's totally valid. It's not like better or worse, or it just is. You could use the law of conservation of energy, LOCO, and say, well, when we're here, we've got gravitational and kinetic energy, and here we've only got kinetic energy. Okay, so we can say, and it says there's no air resistance. That's why we can do this. Where does it say? Neglect air resistance, which means no work is done by the friction of the air, which means we don't lose any energy. So our beginning gravitational plus our beginning kinetic at point A equals the kinetic at point B. Okay, so mgh plus 1/2 mv squared, v at point A equals 1/2 mv at point B squared. All our masses cancel out, or you can plug it in, it doesn't matter. 9.8, the height's 20, plus 1/2. The initial velocity in that y direction is 12. if you do this algebra, you also get, you know what, we'll just do it. 9.8 times 20. Because probably you don't believe me, and that's okay. That's 196. 144 times a half. That's 72. You add them. Divide by a half. Square root it. Well, you know, 23.15. So that's an alternate way to get, if you are more comfortable with the kinematics equations, you can use those. Make your little lists of what you know. Use that to pick what equation you use. Or you can do law of conservation of energy and use that to figure it out. Either way, you have to split the velocity into its components to get useful numbers out of it, 12 and 9. Yeah. If you're pink up fancy, you realize that this is a 3, 4, 5 right triangle. You're just multiplying all the sides by 3. That's okay if you didn't realize that. No worries. That's all I have to say about that, I guess. It's A.